I'm Stephen Tegler. I'm an astronomer at Northern Arizona University, and I work on the Kuiper Belt. Back in 1930 at Lowell Observatory, Clyde Tombaugh discovered Pluto. And very shortly thereafter, it became very apparent that it wasn't very big. And so there's a pattern in the solar system. There's 4 small rocky planets going outward: Mercury, Venus, Earth, and Mars, followed by 4 very large planets: Jupiter, Saturn, Uranus, and Neptune, and then tiny little Pluto. So its size, its small size, its eccentric orbit were very puzzling to astronomers. And then in 1950, an astronomer here again in Arizona, at the University of Arizona, Gerard Kuiper, postulated that there was a swarm of icy planetesimals at and beyond Pluto. And so from 1950 to 1990, that was just a theory. And in 1992, the first Kuiper Belt object was discovered. What the Kuiper Belt is an icy reservoir of preserved building blocks of planets. And so what we have now is an opportunity. There's 1,000 known, so we have an opportunity to understand how you build a planet by looking at the preserved building blocks that are still there. A colleague of mine refers to looking at these images as looking at carpet stains. They're small black dots on a gray background. The dots basically giving us a measure of how bright they are. The most recent run was on the 6.5 meter MMT telescope on Mount Hopkins here in Arizona. And there on a good night, we'll observe maybe half a dozen objects in the course of a night. So what we do at the beginning of the night, just before sunset, we'll show up at the telescope, and we'll meet the telescope operator there, who actually is the one in charge of the telescope, who actually decides when to open, when to close, and has complete control over the facility. At sunset, we rotate the telescope dome and open the slit to such a position that it's optimum for the initial calibration measurements before we begin to make our actual scientific measurements. And then very shortly thereafter, the sun gets down, it becomes dark enough that we can begin scientific operations. We don't do large numbers per night. They are very, very faint. Even now, with brighter ones being discovered, it's a very painstaking, time-consuming process. It's taken us 10 years to do about 100 objects. One of the things that's probably not very well known is that learning how to become a scientist is not just textbooks and homework and exams. That's important, and those are important skills to learn. But to become a scientist, you actually learn that by apprenticeship. At Northern Arizona University, we have an interaction, a close interaction between the faculty and students on research projects. They publish papers and go to telescopes and go to meetings, and they participate in all the steps that are required for a professional scientist. One of the best parts of my job is going to a telescope, and you never know what you may find. Now, most times, nothing of real interest, real significance comes up. But if you're lucky in your career, you'll actually discover something that no one else has seen before, and it's pretty significant. And that is the quest that I think that brings us all to the telescope and stay up all night, is exploring our surroundings, exploring the universe.